Americans were building an advanced technology satellite. We borrowed it from them and moved over to Indian longitude for 1 year because, as some of you are aware, you must have heard of geostationary satellite. That means that satellite, because it is at a distance of 36,000 kilometers from Earth, it takes exactly 24 hours for going around the Earth. That means relative velocity between Earth and the satellite becomes zero. So it appears stationary to you. So if you want to cover large area, you go to higher heights, and this particular satellite at geostationary gives you 1/3 of the global coverage. So you can do line of sight communication, or you can take images and look at how the cloud patterns are moving, how cyclone is formed, where the cyclone hits the land. So this great visionary scientist, Dr. Vikram Sarabhai, within 10 years of our independence, this event had happened. 1947 we got our independence. 1957 the first object was put into space by Russians. At that time, Americans and Russians were really competing with each other to demonstrate who is more powerful, who is strong. But what Dr. Sarabhai was looking at, how a new capability of putting satellites into space can be used for rapid development in the country. We had just got our independence, and for many centuries India had been plundered by our occupants of our resources, and poverty levels in our country had come down to very, very low levels. And if you had to make rapid development, the only mechanism was make use of science and technology for finding solutions. So Dr. Sarabhai was looking at how this technology of space can be used for bringing in rapid benefits, where the entire country can be connected in telecommunication, broadcasting, and also in terms of when weather vagaries of cyclones and super cyclones occur, how we can provide information to our people living in the coastline. So just for the sake of this thing, in the recent past couple of weeks back, you would have heard one cyclone, super cyclone, hit Orissa coast. In the earlier decades, a cyclone of that magnitude would have resulted in loss of life of almost 15 to 20,000 people, because you don't know when the cyclone is coming, so you are not prepared for that. But today, by looking at the cloud motion, by looking at how these cloud patterns form, how they move, and also making use of a number of other observations from satellites, it is possible for us to give information almost 4 to 5 days in advance. What location on the coast this particular cyclone comes and hits. So as a result of that, disaster relief agencies can actually vacate the people and save their lives. So in the recent past, many of the super cyclones, India has been able to save the lives of the people who would have otherwise lost their lives. In fact, not only United Nations, the entire globe actually applauded the manner in which India dealt with this particular super cyclone and then saved the lives of the people. And in a similar manner, today communication, you have direct-to-home television, or looking at whether when you go to a ATM, how the ATM gets connected to the bank and the events happen. For all this, we are making use of the satellite capability. We also have satellites which can take images of any part of the globe, and not only any part of the globe, but even within our own country also, we can take images in different wavelengths. You are familiar, between June and September, India is covered with clouds, monsoon clouds. So obviously, if you are trying to look from space down to Earth, over India, what will you see? Clouds. So you can't get data. But to overcome such problems, it is possible to use a particular wavelength of radiation called microwave. Like glass is transparent to us, we can see through glass. Same way, through the microwave signals can penetrate through the clouds, and you can look at what is happening. So we have a number of satellites providing such images, and all this data, when it comes, the data is received in a place called Shadnagar here, where you have a ground station, and in the antenna you receive the signal coming from the satellite. Now that signal has to be converted into data. That particular data has to be converted into information, like whether you want to know what is the crop that is being grown in a particular region, or what is the amount of rice that will be grown this year, wheat or sugar cane, jute, cotton. So today, based on the satellite data, it's possible to determine how much is going to be the yield even before the actual harvesting is done. And similarly, one of the things that was being talked about here is Amrut, where using very high resolution data, you can convert that into a planning activity. We have a large number of towns which are going to be actually, you will have new constructions and new buildings coming up, a complete master plan preparing for that. So for that, people are working here, and then they are working for about 250 odd towns, and we have many more towns for which such work has to be done. So like this, today what ISRO has demonstrated, that it is capable of making use of space technology, using that. In fact, India is among the few countries in the world which has an end-to-end capability of building instruments, satellites, launch vehicles, and also the application. While we have our own launcher called PSLV, which has done almost 46 successful missions, and in this you are also aware that we launched 104 satellites in one go. It's a sort of a world record. And similarly, this launch vehicle has also put a satellite called Chandrayaan-1, where man had landed on the moon, but a large number of probes had gone around the moon. But still, the credit for discovery of presence of water on the moon and the process of water molecule formation on the moon, the credit for discovering that goes to Chandrayaan-1. In a similar manner, if you look at Mars mission, there also, we were the first country to actually put a satellite going around the Mars in its very first attempt. While people had been doing a lot of missions, out of 53 odd missions, only 22 missions had been successful. So we were the first to achieve in our maiden attempt. In the same way, if you look at a satellite called AstroSat, today this satellite carries the world's best telescope in a particular wavelength region called far ultraviolet. Why I am telling you all this is, you may feel that there are advanced countries, West, where they have gone far ahead of us, whether we will be able to do anything meaningful. You can see that all these examples what I have given, where you have an indigenous capability of making use of this space technology for bringing in services to the society, whether it is for cyclone or whether it is for communication, broadcasting, or even telling the fishermen where to go for fishing. Today the capability established by ISRO enables a fisherman, when he is in the ocean, using his mobile, he gets message in the form of a video compass. He can be actually guided to go to the place where fish is available, and also in his mother tongue he can be given advisory of any impending weather danger that will occur in the coming days. So all this has been possible because people